In this three-dimensional graph, we're going to compare the factors that maintain blood pressure, examining specifically after a drop in blood pressure over time. And what we see here is the relative effectiveness of these particular parameters on our y-axis. We have the parameters themselves on our x-axis, and then on our z-axis we have time over here. And so early onset actions occur towards the front of this graph, and later onset ones will occur toward the end of this graph. And let's examine them one by one. And what we see is that baroreceptors of the carotid sinus and the aortic arch are by far the fastest and strongest response to an immediate drop in blood pressure. These guys will immediately stimulate an increase in sympathetic output to the heart, to the blood vessels, increasing cardiac output, increasing total peripheral resistance, and boosting our blood pressure. Right behind them are also a neural response, the chemoreceptors. These are found in the carotid bodies and the aortic bodies. These sense oxygen levels, CO2 levels, and pH levels. And if blood pressure falls, remember, pressure drives flow. So if flow is depressed, we're going to have tissues become more hypoxic and more hypercapnic. That would stimulate these chemoreceptors to activate a sympathetic response, once again boosting blood pressure and blood flow. After that, after 15 minutes or so, we're going to start to have hormonal regulation of that blood pressure, specifically angiotensin II. The renin secreting cells of the kidney are sensitive to that fall in blood pressure. We're going to get an increase in renin. We'll get an increase in angiotensin II. That vasoconstriction will kick in and cause further vasoconstriction and a rise in total peripheral resistance. It's going to be added on top of the already occurring sympathetic response. We would also get a capillary fluid shift. The hypotension, the fall in blood pressure, would reduce a filtrative force at the capillaries that would enhance reabsorption, boosting blood volume. Boosting blood volume aids venous return to the heart, which increases stroke volume and cardiac output, therefore boosting blood pressure long term. Finally, we have renal blood volume control aiding our blood pressure. This is exceptionally potent, has enormous potential for helping us maintain our blood pressure, largely through the actions of aldosterone and ADH that cause reabsorption at the renal nephrons, boosting blood volume by decreasing urine volume, and in that process, once again, increasing central venous pressure, venous return, and cardiac output.